This video recaps chapter 6 from the Higher GCSE book, and this is all about angles and different angle rules. Now, one thing I want to highlight is that when you do angles at GCSE, quite often diagrams are not drawn accurately, and it will normally say that. So what that means is that you don't measure the angles. So don't measure. Yeah, that means most of the questions you're going to be doing, you are going to be using some sort of rule to find the missing angle. Now, the only questions I know of where you're measuring an angle may be a bearings question. So, may measure on a bearings question, and that's normally where you need to draw a bearing. Other than that, what you need to do is to use angle rules, and we're going to start with these rules here. It does come up in another chapter, angle rules, but it's to do with what we call circle theorems. So it starts off nice and straightforward. Angles on a straight line, okay, they add up to 180. So here's like a little diagram of a straight line like this. And we've got that. That's the first angle rule. Second angle rule, angles round a point, add up to 360, add up to 360 or equal 360. So if you've got some sort of point here and we go all the way around, that's going to be 360 degrees. Angles in a triangle, okay, they add up to 180. And angles in a quadrilateral, so that's any four-sided shape, add up to 360. So far the only angles that we've got are 180 and 360. Okay, so that covers this first section here, angles round a line or point, and we've done this, finding angles in triangles and quadrilaterals. Now we're going to move on to angles in polygons. So polygons, or polygon, the word polygon just means many sides. Now it can have from one side, you can have one sided polygon up to lots of sides, 10, 20, 30, 50 sides. And what we want to be able to do is to find the angles in a polygon. We want some sort of rule. So what I'm going to do is let's draw a pentagon. Okay, so you've got 5 sides there. Okay, not the best pentagon in the world, but it's got 5 sides. Now what I'm going to do is I'm going to pick a corner and I'm going to draw a line from that corner to all the other corners. Can you see now that this shape has been divided up into 1, 2, 3 triangles? Okay, so I've got a pentagon here, which is a 5-sided polygon. And what I can see is I've got 3 triangles. Now we've just done the rules for finding angles in a triangle, and that's 180. So if I do 3 times 180, it tells me that the total of the angles in that shape is 540 degrees. Okay, let's move on to 6 sides and see what happens. So 1, 2, 3, 4, 5, 6. Okay, there's another badly drawn 6-sided shape, hexagon. I'm going to pick a corner and just draw a line from that corner to all the other corners. These lines are called diagonals. Now what happens here? How many triangles do I get? 1, 2, 3, 4. Okay, so in this hexagon, which has got 6 sides, I've got 4 triangles, so the total of the angles inside is 4 times 180, which is 720. Now you may have seen a pattern here, and that is if I look at the number of sides, can you see that the number of triangles is 2 less than the number of sides? So here I had 5 sides, 3 triangles. Here I had 6 sides, 4 triangles. So if I do the number of sides, take away 2, I get the number of triangles. If I multiply that by 180, I get the angle total in the polygon. It doesn't matter how many sides it's got. Okay, so this bit here, where we're doing a number of sides minus 2, what we're working out there basically is the number of triangles. So here's an example. If I had a 45-sided polygon and I wanted to know what the angles in that 45-sided polygon added up to, so I wanted to find the angle total. 45 minus 2 tells me that would split up into 43 triangles, times by 180 gives me the angle total. So let's work that out. So 45 minus 2 is 43, 43 triangles, 43 times by 180, 7740. So the angle total in a 45-sided shape would be 7,740. So we can use this to work out what the angles add up to in any sided polygon. Just take the number of sides, take away 2, and then multiply by 180. So here we've just said we can find angles in polygons. So that finishes off that bit. The next bit is finding interior and exterior angles in a polygon. Now the word interior basically means inside. So because they're angles, the interior angle is basically inside the shape. An exterior angle is outside the shape. So what do they look like? Right, I'm going to draw a hexagon like this. Okay, and these angles here, these are the interior angles. So these are the angles inside all of these here, and there's 6 of them. Number of angles is always the same as the number of sides. So what we've got here, these are the interior angles, and we know how to work out the total of those. We can take the number of sides, take away 2, multiply by 180, and find the angle total of the interior angles. Now if I take each side and I extend it so it looks a bit like a fan, like this, so all I'm doing is making each side a bit longer and making them all longer in the same direction. The angles that I create on the outside, so these angles here in green, like this, inside that fan bit, these are called exterior angles because they're now outside the shape. Okay, so all of these green ones here, all the way around, they're called exterior angles. Now, if we have a look, can you see that all around the shape, you've got an interior and exterior angle next to each other? Yeah, there's a pair there, there's a pair there, all the way around. And this is just a straight line. I've made like the sides longer by just doing a straight line. Now, because these two angles on the straight line, the interior angle plus the exterior angle next to it always add up to 180. So let's write that down. The interior and exterior angles next to each other add up to 180 degrees. Okay, this is going to be useful later on. There's also another feature about exterior angles. So if I look at all of these exterior angles here, these green ones, if I were to add them up and measure them and add them up, they would add up to 360 degrees. Now that's true for any polygon. whether it's got 3 sides, 4 sides, 100 sides. These exterior angles, when they're all added up, will always make 360 degrees. That's always true. So we can write down another rule, which is this: the sum, or the total, of the exterior angles, all of the exterior angles, is always 360 degrees. It's always 360. Even if the angle total inside, so even if these ones inside added up, gets bigger and bigger and bigger. So I think we did that 45-sided shape and it was like 7,700 and something. The exterior angles would always add up to 360, and that's a useful feature. Now at this point I'm going to introduce something called regular polygons, because quite often these questions involve regular polygons. Now regular polygon is one where it's a nice looking one because all the angles are the same size and all the lengths are the same. So regular polygon, all sides the same length and all angles the same size. All angles the same size. Now when I say all angles the same size, that is the interior angles are all the same size, interior, and the exterior angles are all the same size. So for example, if I had a regular, octagon. Okay, so octagon's an 8-sided shape. I'm not sure why I put E on the end. I'm going to attempt to draw one. 1, 2, 3, 4, 5. No, it's not regular at all, is it? 5, 6, 7. Now pretend all of these sides are the same length. It's not very good. But imagine all of these sides here are all the same length. In fact, let me rub that out. It's terrible. So in a regular octagon, we have 8 sides all the same, 8 sides, and we have 8 angles all the same, 8 angles all the same. Okay, so what does that mean? Right, let's find the total of the angles in a regular polygon. So angle total, in a regular octagon, sorry, angle total equals number of sides minus 2, 8 minus 2 times by 180. So let's do that. That's going to be 8 minus 2 is 6. 6 times 180, and we get 1080. So the angle total in a regular octagon, in fact any octagon, is 1080. Now since it's regular and all the angles are the same, if I do 1080 divided by 8, I find the size of one angle in a regular octagon. So I'm going to do 1080 divided by 8, and I get 135. So each interior angle in a regular octagon would be 135 degrees. So that's the interior angle. Now, because the interior and exterior add up to 180, if I wanted to find the exterior angle, all I would do is do 180 minus the interior angle 135. And the exterior angle, if I do 180 minus 135, 180 minus 135, I get 45. 45 degrees. Now there's another way I could have got that 45. What did I say about exterior angles? Exterior angles add up to 360 degrees. If I've got a regular octagon, they're all the same and there's 8 of them. So 360 divided by 8. And if I do 360 divided by 8, I also get 45. Yeah, so that's another way of working out the exterior angle. Now I've seen a lot of questions in exams, something like this. So it's drawn a part of a polygon and it will say something like this: not to scale. Okay, so this is a part of a polygon and they've only drawn a part of it. Okay, so here is a drawing of part of a polygon, and then it does something like this. It maybe gives you an angle Okay, so let's put an angle in there. Okay, and let's say that this angle is 165 degrees. So here we've got 165 degrees. Okay, here is a part of and that should actually say a regular polygon of because we wouldn't be able to answer this question otherwise if it wasn't a regular polygon. Regular polygon, and then it goes on to ask, how many sides does it have? How many sides does it have? So how do we do that? Well, what we do is we start by working out the exterior angle. So if I add that there, we're going to work out this angle here, the exterior angle. So step number one, we'll work out the exterior angle. So exterior angle equals 180, because exterior and interior add up to 180. Take away 165 and I get 15 degrees. Now, why have I worked out the exterior angle? Because we know the exterior angles all add up to 360. And if this is a regular polygon, where we know that all the angles are the same, so in a regular polygon, all the exterior angles are the same. They're all going to be 15. All the exterior angles are the same. And they add up to 360. And they add up to 360 degrees. So how can we find a number of sides? Well, if we do 360, that's the total, divided by 15, we're basically finding out how many times 15 goes into 360. So 360 divided by 15, we get 24. So this tells me this polygon has 24 sides. And I found all of that just by using the information that's been given. It gives me the interior angle. I find the exterior angle, which I know I found that is 15. And then I'll find out how many times does 15 go into 360, 24 sides. Now this little trick here that we're doing only works with regular polygons because we know they're the same. If they're all different and it's not a regular polygon, you can't find how many sides it's got using this method. We'd have to be given more information to be able to answer this questions. Now there is a little bit on here that's actually that we need to add to do with angles, which is not actually listed here, but it's in the book. So the next thing we're going to be looking at is angles in parallel lines. So these are the angles that we get when we've got parallel lines. So if I were to draw a couple of parallel lines like this, great parallel lines, and I was to draw a line going across them like this, what we create are actually 8 different angles. There's an angle here, 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 one here, one here, and one here. And in fact, I've deliberately color coded them because the angles which are the same color, put lines on this, show the parallel, the angles which are the same color are the same size. The angles which are the same color are the same size. So actually there are only 2 types of angle here, and if we know just one of them, we can work out all of them. So for example, if this one here was 60, then that's 60, this is 60, this is 60. Now the ones which are opposite each other, there's a rule that says when you've got 2 straight lines that cross like this, if these angles are equal, they're called vertically opposite. So vertically opposite angles are equal. Okay, and we could actually work out these ones here. These would be 120 because we've got straight lines. 120 there. So with just information about one angle, we can find all of them because we've got information here. Like these are straight lines, these are straight lines. So angles on a straight line add up to 180. Okay, now what other rules do we get with parallel lines? Right, here's one. Here's two parallel lines like this, and I'm going to draw a line that goes across them. And this angle here and this one are the same. Now, you may or may not be able to see like a F shape, so a bit like this, and it's the angles hanging from the F. Now, this F may be drawn, you may see the angle, so it's back to front, so back to front F like this. The F may be upside down like this, yeah, but it's basically like the same position, like this. Those angles are the same. So these angles like this, which are the same, are called corresponding. Corresponding angles are equal. Now, how do I remember they're called corresponding? Well, it's an F angle and it's called corresponding. So things like football club, you know, Manchester FC, that type of thing, football club, is going to help you remember that if you see the F, it's corresponding. Okay, what other angle rules do we get? So let's draw another set of parallel lines. Let's draw another line going across them. Let's make it slope the other way. And let's do an angle here and an angle here. Now you may or may not be able to see a Z shape. So what we have is like a Z. Yeah, it may be back to front like that. The Z may be upside down or going the right way around like this. So whenever you see this Z, this Z, those angles are the same. Now these angles are called alternate. So the second rule is alternate angles are equal. Alternate angles are equal. Now, how are we going to remember this? Well, alternate angles look like a Z. So maybe A to Z, the first letter of the alphabet, the last letter of the alphabet, is going to help you remember those. And there's one more with parallel lines. Let's do that over here. So set parallel lines like this. A line going across them like this. Now these angles, this one here, the ones tucked in on the inside, those ones aren't equal, but they add up to 180. Now you may or may not be able to see, sometimes it looks like a C shape, like that. If the parallel lines are going the other way, like if they're both going down, it might look like a U shape. You'll find this in particular when you're dealing with bearings, because these are going to be like north lines. Bearings is the next thing that we do. And these are called co-interior. They've got lots of different names. They've got like 2 or 3 different names, but we're going to call them co-interior. And co-interior angles add up to 180 degrees. Yeah, they can be called supplementary angles, complementary angles. We're going to call them co-interior. Now, how can we remember co-interior? Look at the C, and like we got like something that looks like a C shape. Now, as I said, the C may be back to front like this. It may be upside down. We're looking for the parallel sides and the line, the angles which are inside. Okay, so these angle rules are, as I said, not in the recap section of the book, but they need to be added. Last thing I'm going to be looking at is scale drawings and bearings. So let's start with scale drawings. Scale drawings. And with scale drawings, you'll always have a scale which is something like this. Let's say 1 to 5,000. Right, the number at the front is always 1. So it's always 1 there. Always 1. And this number represents the measurement in the map or model. So you've got some sort of map or scale drawing. It represents the measurement in the map or the model, whereas the second number can be any number, but this represents the measurement in real life. Measurement in real life. So what does that mean? Well, for something like this, what it means is that for every one measurement in the model, it's worth 5,000 in real life. So if something measured 1 millimeter in a model or a map, it would measure 5,000 millimeters in real life. Or if something measured 5,000 millimeters in real life, or 5,000 inches, or 5,000 miles, then on the map or the model, it will represent 1 inch or 1 millimeter or 1 mile. And when we do questions like this, you start by writing out what the scale is. So let's use 1 to 5,000 again. So let's say that we had a model car, and the car was made to this scale. And let's say in the car, a wheel measures 2 millimeters. And we want to know how big is the wheel in real life. So since it's a model measurement, the 2 goes underneath here on the model side, the map side. That means we times by 2, times by 2. So the missing number here is 10,000. So that means that in real life, the wheel measures 10,000 millimeters. Yeah. Or it may be a question that goes the other way. So let's say, for example, it was, let's say, a map. And let's say on a map, so on, or let's say in real life. So in real life, 2 towns are 15,000 miles apart. I know it's a long way apart. Don't worry about it. And I want to know how far they are in the map. So on the map, how far apart are these towns? Right, so what I've been given here is a real life measurement. The real life goes underneath the 5,000, so I put 15,000. And like before, we're going to work out the missing number. In here, we times by 3. So on the map, it will be 3 millimeters or 3 inches, 3 centimeters. It all depends on the units that we are using. Now, on questions like this, you'll quite often need to convert between centimeters, millimeters, meters and kilometers. So this is how we do it. So millimeters, centimeters, meters, kilometers. Right, so if you want to change centimeters to millimeters to centimeters, you divide by 10. If I want to change centimeters to meters, I divide by 100. And then if I want to change meters to kilometers, I divide by 1,000. If I want to change kilometers to meters, I times by 1,000. If I want to change meters to centimeters, I times by 100. And if I need to change centimeters to millimeters, we times by 10. Now, I think we did a question a minute ago, and we ended up with something like, let's say we ended up with a measurement of 15,000 millimeters, and it says it wants the answer in meters. Okay, so we divide that by 10. So that would be 1,500 centimeters. If I divide that by 100, that will be 15 meters. 15 meters. And if it was a bigger measurement, I could then change it to kilometers. So that's our work on scale drawing. So the last thing we're going to be looking at is bearings. So bearings. So bearings are used where there are no roads or signs, things like that. So they're used to help direct planes and traffic in the sea. So the only thing that's the same anywhere is where north is, magnetic north. So these things will have compasses. A compass always points north. So with bearings, we measure from the north, and whenever you get these questions, north is normally pointing up on your page, and north is like 0 degrees, 0 degrees. Now, with bearings, the second thing that we do is that we use three figures. So we don't just, you know, if it's 18 degrees, you say 0, 1, 8, and so on. So that means 0 degrees is actually 0, 0, 0. Okay, so let's say I want to get to this spot here, and this is barking. And I want to know what's the bearing to barking from, let's say this is Dagenham. So I want to know what is the bearing to Barking. How do I get to Barking from Dagenham? Right, so what I would need to do, I'd probably have some sort of line like this, and another north line here. And what I would need to do, how do I get to Barking from Dagenham? Now the wording will be like this: the bearing of Barking from Dagenham. So where am I measuring it from? I'm measuring it from Dagenham. That would be this angle here. Now, why didn't I go around the other way? That's because bearings are measured clockwise. Okay, so that's the last thing to write with bearings, measured clockwise. Now, because the north lines are parallel, see they're parallel, we can use rules to do with parallel lines. So for example, let's put an angle on here. Let's take this out. Let's say that this angle here was a bearing of 120 degrees. Okay, so the bearing of Barking from Dagenham is actually 120 degrees. Let's say I wanted to work out the bearing or the direction of Dagenham from Barking. In other words, what's the direction I need to go in to get to Dagenham from Barking? So now I'm actually starting here and I want to go that way. Now I need to make sure that I work out this angle here, the clockwise angle. So can I use angles with parallel lines to help me? Yes, I can, because here we have like this U shape with parallel lines, and what we know is that these two angles here add up to 180. So if that one up the top there is 120, this one here must be 60. 120 plus 60 is 180. Now down the bottom here we've got angles around a point down here. So if that's 60, I can take 60 away from 360, and that will give me a bearing of 300. So to finish this off, the bearing of Dagenham, or Barking from Dagenham, would be 300 degrees. So we can use the rules for parallel lines to help us answer these questions, because north lines like this are always going to be parallel. So if I've got something like this, okay, these are parallel. I know that this angle here, they all add up to 180 degrees and helps us find the solutions to these problems.